For problems 73 and 75, I also included, I see what we're going to be needing over here. Number 75, we're going to need to remember some of these properties of exponents. So I just wanted to keep those there for you. And in solving problem 73, we recognize that it's an exponential equation because the variables are in the exponents. And we notice that 3 and 27 can be both written as a power of 3. Well, of course, 3 is already written as a power of 3. So we leave that side alone, but 27, we're going to go ahead and rewrite that as 3 cubed. And so again, knowing your powers of 2, 4, and 5, that's really, really important in this section here. So let's go ahead and simplify the right side. Let's multiply out 3 and 2x. So 3 times 2x. Again, power to a power, we're going to multiply. 3 times 2x is 6x. And we have the bases the same, so therefore the exponents have to be equal. And let's not do too much at once. So we equate the exponents. Now we have a quadratic equation. So notice we have an exponent, but it's not the variable. It's a number, a real number. And when we have a real number exponent, then and it happens to be a 2, that's the highest power here. We have a polynomial equation, polynomial specifically highest power 2, meaning we have a quadratic equation. So solving quadratics, just to remind you, we want to gather all the terms to one side, so we're going to subtract 6x from both sides. And then in solving this particular one, we can go ahead and factor. There's 3 terms, and so we're going to factor using the FOIL method. We need factors of -7 that have factors of -7 that whose sum is -6. So that's -7 and +1. So since we have the left side factored, we're going to set each factor equal to 0. And when x plus 1 equals 0, we know that x has to equal -1. And if x minus 7 equals 0, then that means that x would equal 7. So we have 2 solutions to the original equation. And so that's got a lot of good stuff in it, because we not only had to solve an exponential equation, but we also had to solve a quadratic equation. So it's a good review question for you. Hopefully you're not struggling with that. It's a good reminder of how to solve a quadratic equation. Now, for number 75, before we start working with the letter or the number E in number 77 and 79, then we're going to go ahead and we see something we haven't seen yet. And one thing to consider here is you don't want to get too hasty. You don't want to, oh, you see a 4 times a 2, your mind wants to put an 8 right there, but that's totally incorrect. You can't combine. Notice here, if you think about the properties of exponents, you can't combine the 4 and the 2. If it's just 4 times 2, fine, but it's not. It's 4 to the x and 2 to something else. And so therefore we have to make sure that these 2 bases are the same. So we're going to go ahead and notice that 4, 2, and 16 can all be written as powers of 2. So we're going to do that first. Make sure you express every single base as each term, I should say, or each even factor as a power of the same number. So we want to rewrite every single one of these with a base of 2. 4 is 2 to the second. 2 is already that 2. 16 is 2 to the fourth. So again, we're going to rewrite every single term as 2 to some power. And then we're going to go ahead and use the properties again. Power to a power, we get 2 to the second power to the x. So we multiply the 2 times the x. I was trying to figure out a better way to say that. Maybe it's getting late. And then we have 2 already to the x squared. Oops, 2 to the x squared. And then we have 2 to the fourth to the second. So 4 times 2 is 8. So we have 2 to the 8th power over there. Now, before we equate anything, we can't yet until we get just one term on the left-hand side. In other words, 2 to some power on the left and then 2 to some power on the right. That's when we can use this third property. So in order to combine the 2 terms on the left-hand side, we have to use this property here, where if the bases are the same, then you're multiplying the bases. You're multiplying 2 terms whose bases are the same. You add the exponents. And so that's what we're going to do. We're going to rewrite this left side as 2 to the, we're going to add the 2x to the x squared, and on the right side we just keep that as our 8. Now we finally, after the dust has settled here a little bit, we see that the left side and the right side both can be expressed as a power of 2. So therefore then we get to go ahead and equate the exponents. So that's the toughest part of the problem right there. And then again, we have a quadratic equation. Let's go ahead and rewrite the terms in order. We're going to subtract that 8 from both sides, and then we're going to go ahead and factor x plus 4, x minus 2 equals 0. So therefore x equals negative 4, setting that factor equal to 0, and setting that second factor equal to 0. We see we have two solutions to this equation, and they are negative 4 and positive 2.